Hey everybody, welcome back to my channel. This is WireDogSec back with another video for you guys. Today's video, we are in TryHackMe Advent of Cyber 2024 event. We are continuing on. This is day number 8. And if we scroll down here to the task, it's task number 14, Shellcodes. Day 8, Shellcodes of the World Unite. Alright, hopefully y'all are having an awesome day today. You're ready to learn something. So let's go ahead and take a look at what's going on here. Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. To save on time, I would recommend starting the attack box and the machine for this room, if there's a machine for the room. So I recommend starting both of them before you even start reading through the room. That way you can save some time possibly. But let's go ahead and get into it. The story, Glitch the hacker, clever yet distrusted, wrote a script with skills finally adjusted. Shellcode magic to his home it would send, where secrets of Wareville he'd carefully penned. Glitch, a skilled but mistrusted hacker, was prepping for a tech conference. He was eager to share his shellcode script that remotely accessed his home system. As he worked, he noticed Mayor Mauer's henchmen lurking nearby. They're wasting their time. I don't have anything they'd want, Glitch chuckled. He didn't realize that hidden in his home system was something they desperately sought. A research paper he wrote on Wereville's defenses, a treasure Mayor Malware was eager to obtain, learning objectives, grasp the fundamentals of writing shellcode, generate shellcode for reverse shells, executing shellcode with PowerShell. And this is what you need for today's room here. Do you need to start the attack box? Yes. Do you need to start a VM? Yes. Is there split screen available? Yes. But I'm going to flip back and forth just to make sure that the screen's big enough for you guys. All right, I've already started the machine. Here's instructions on how to do that here, how to start the attack box. All right. Essential terminologies. A reverse shell to his system too tight. He planned to showcase at the tech conference night, eager to share how his shellcode could impress. He aimed to enlighten, to teach, and progress. Before we start, review some important concepts to help you better understand the upcoming content. Shellcode is an advanced topic, but knowing these foundational ideas will make the rest of the material more accessible and engaging. Shellcode. A piece of code usually used by malicious actors during exploits like buffer overflows, attacks to ingest or inject commands into a vulnerable system, often leading to executing arbitrary commands or giving attackers control over a compromised machine. Shellcode is typically written in assembly language and delivered through various techniques depending on the exploited vulnerability. PowerShell, a PowerShell or powerful scripting language and command line shell built into Windows for task automation and configuration management. It allows users to interact with system components and is widely used by administrators for legitimate purposes. However, attackers often use PowerShell as a post-exploitation tool because of its deep access to system resources and ability to run scripts directly in memory, avoiding disk-based detection mechanisms. Windows Defender, a built-in security feature that detects and prevents malicious scripts, including PowerShell-based attacks, by scanning code at runtime. Common bypass methods for invading Defender include obfuscating scripts to disguise malicious content, making it harder for the software to recognize known patterns. Another technique is a reflective injection where malicious code is loaded directly into memory, avoiding detection by signature-based defenses. We will cover the latter one in the task, Windows API. The Windows Application Programming Interface API allows programs to interact with the underlying operating system, giving them access to essential system-level functions such as memory management, file operations, and networking. It serves as a bridge between the application and the operating system, enabling efficient resource handling. The Windows API is crucial because many exploitation techniques and malware rely on it to manipulate processes, allocate memory, and execute shellcodes. Common Windows API functions frequently used by malicious actors include virtual alloc, create thread, wait for single object, which we will also use in this task for exploitation. Accessing Windows API through PowerShell reflection. Windows API via PowerShell reflection is an advanced technique that enables dynamic interaction with the Windows API from PowerShell. Instead of relying on precompiled binaries, PowerShell reflection allows attackers to call Windows API functions directly at runtime. This will enable them to manipulate low-level system processes, making it a primary tool for bypassing security mechanisms, interacting with the operating system, and executing code stealthily. Reverse shell, a type of connection in which the target, the machine you're trying to hack, initiates a connection back to your attacking machine. In this case, your machine will be the attack box. And here's a infographic of what they're talking about here. So this is your machine, the attacker. There's a reverse shell. There's the victim. Okay, reverse shell is on the victim's machine. It's connecting back to the attacker box, which is your machine here, right? So it's connecting back on port 4444. Generating shellcode. But Mayor Malware's minions, sneaky and sly, found his script and gave it a try. They tampered the code, changed port and IP, twisted his work with a sinister glee. Let's learn how to generate a shellcode to see what it looks like. To do this, we will use a tool called MSFvenom, a classic, to get a reverse shell. In the attack box, open the terminal, enter this command. All right, we're going to copy and paste here. So we're using MSFvenom-P, Windows x64. That's the architecture of it. Shell underscore verse TCP L host is going to be attack box IP, so whatever yours is going to be, that's what you're going to plug in there. Then the L port, the local port is going to be 1111 -F, and then PowerShell -F, I believe is the format, stands for format. Since that will generate the shellcode, the output will look like the following. You're required to replace the attack box IP with one of your attack box. Okay, so it's pretty straightforward. And let's go ahead and do that. Let's see if I can make this bigger. Okay, and I'm just going to create a new tab here. Get rid of that. Of course, make this bigger here. There we go. And we are going to paste. And then, of course, we're going to replace this IP address. Okay, 10.10.128.172. And I forgot the last L in that, so let me fix that real quick. There. Now it should run. It could take a couple minutes or so, depending on the speed of your machine. All right, well, that's loading up. Let's take a look over here. But we should get something that looks like this here. All right. Says the above command generates a piece of shellcode using MSFvenom. Here's what each part means. And let's see if it finished. Yes, it did. Okay, we've got the similar output as they did, it looks like. All right, so it's -P, Windows, etc., etc. The -P flag tells MSFvenom what type of payload to create. So that's the payload here. Specifies that we want a reverse shell for a Windows machine. The lhost, this is the IP address of the attack box. It tells the reverse shell where to connect back to. L port 1111. This is the port number on the machine that will listen for the reverse shell connection. When the target connects back to you, it will use this port 1111 in this example. You can use any available port, but it needs to match what your listener is set to. -F PowerShell. This specifies the format for the output. In this case, we want the payload to be in PowerShell format so it can be executed as a script on a Windows machine. Ideally, for these ports here, you want to use something that can blend in with the normal traffic if you're trying to be sneaky, right? But anyway, where is the actual shellcode? The actual shellcode is, or in the output above, is the hex encoded byte array, which starts with 0xFC, 0xE8, and 0x82, and so on. The hexadecimal numbers represent the instructions set on the target machine. Computers understand binary, ones and zeros, but hex numbers are just a more human readable version. So instead of seeing long strings of ones and zeros, you are seeing something like 0xFC instead. We can execute this shellcode by loading it into memory and then creating a thread for its execution. In this case, we'll use PowerShell to call a few API or Windows APIs via C# code. Below is a simple PowerShell script that will execute our shellcode. And this is what it looks like here. So I wonder if we need to copy this. Let me go ahead and get it ready to go. All right. And it looks like we need to put our shellcode right here. But yeah. All right, let's see here. It says, phew, a lot of code. But don't stress. we'll break down what it does step by step. If you're new to cybersecurity, memorizing these functions is unnecessary. Most penetration testers use pre-made or automated tools to run shellcode, so you don't have to know every technical detail to complete the job. No need to worry. Explanation of the code. The script starts by defining a few C-sharp classes. These classes use the DLL import attribute to load specific functions from the kernel 32 DLL, which is part of the Windows API. Virtual alloc. This function allocates memory in the process's address space. It's commonly used in scenarios like this to prepare memory for storing and executing shellcode. Create thread. This function creates a new thread in the process. The thread will execute the shellcode that has been loaded into memory. Wait for single object. This function pauses execution until a specific thread finishes its task. In this case, it ensures that the shellcode has completed execution. These classes are then added to PowerShell using add-type command, allowing PowerShell to use these functions. Sounds pretty neat. Storing the shellcode in a byte array. Next, the script stores the shellcode in the $buff variable, a byte array. In the example above, shellcode placeholder is just there to show you where you would insert the actual shellcode earlier generated through MSFvenom. Usually, you'd place it with the real shellcode, represented as a series of hexadecimal values. These hex values are the instructions that will be executed when the shellcode runs. Allocating memory for the shellcode. The virtual alloc function then allocates a block of memory where the shellcode will be stored. The script uses the following arguments: 0 for the memory address, meaning that Windows will decide where to allocate the memory; $size for the size of the memory block, which is determined by the length of the shellcode; 0x3000 for the allocation type, which tells Windows to reserve and commit the memory. You got 0x40 for memory protection. The memory is readable and executable, necessary for executing shellcode. After memory is allocated, the marshal.copy function copies the shellcode from the $buff array into the allocated memory address $address, preparing it for execution, executing the shellcode, and waiting for completion. Once the shellcode is stored in memory, the script calls the createThread function to execute the shellcode by creating a new thread. This thread is instructed to start execution from the memory address where the shellcode is located, $address. The script then uses the wait for single object function, ensuring it waits for the shellcode execution to finish before continuing. This makes sure that the shellcode runs completely before the script ends in execution. Time for some action, executing the shellcode. On the attack box, execute the following command. So netcat dash nvlp 1111 to start a listener on port 1111 and wait for an incoming connection. This command opens the port 1111 and listens for connections, allowing the attack box to receive data once a connection is made. So I'm going to copy and paste here. Okay. And I'm just going to open up a new tab. Paste this in there. Bam. Now we got our listener ready to go. On the attack box, begin by navigating to the desktop, right-click on the desktop, and create document, and choose empty file. Open this new file and paste the previously provided PowerShell script code into it. Look for the part labeled shellcode underscore placeholder and replace it with the shellcode we previously created with MSFvenom. So we're going to copy and paste again. Okay, and Control Shift A, then Control C. Okay, got everything ready to copy. And let's go over, minimize this. Okay, we are on the desktop. Create a file. Right, create document, empty file. It didn't say what to name it, did it? Well, let's just name it, I guess, shell dot ps1. All right, let's go ahead and plug this in. Okay, open with Pluma. Paste. Now we need to grab our shellcode that we generated earlier in this tab. Okay, there it is. And we need to get everything from here, I believe. So copy, make sure. It's been a while since I've done this one. Yeah, byte. Okay. All right, we don't need that byte thing. Okay, we'll just take that out of there, and then we just need this here. Okay, copy. Minimize this. Go back over here. Make this a little bit bigger. Scroll down. There it is, placeholder. Delete all the stuff out of here. Control B, paste. There we go. Looks good to go. Control S, save the file. Now it looks good. Let's flip back over here and take a look at what's going on. All right, it says once you've added the shellcode, navigate to the attached VM, open PowerShell by clicking the PowerShell icon on the taskbar and paste parts of the code from the document you recently created to the Windows PowerShell window. For example, the first part to copy and paste is the block below. So let's go ahead and do that then. Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. All right, I have everything from here, copy and pasted over here, as you can see there. Now, make sure that it looks exactly like this screenshot. Otherwise, it's not going to work, as you can see here. So you can copy and paste up into, it gets to this at right there, and then it gets to add type, right? So make sure to make sure those are separate lines, it looks like, okay? And then especially at the bottom here, these are all separate lines, and they even say that too, right there. So anyway, so I'm on the last line, hit enter, and let's see if it works. There we go, finally. All right, now we hit dir, and we have access to the machine, so who am I? There we are, host name. So it's standard stuff when you get into a machine. But we have access to it, so let's continue on here. All right, we already did this here. We're gaining access. Now Glitch must act. No time to delay to fix the shellcode and keep foes at bay. He tweaks and he codes to set the wrongs right, protecting his secrets with all of his might. Let's dive into the story and troubleshoot the issue in the part of the task. Uh, Glitch has realized he's no longer receiving incoming connections from his home base. Mayor Malware's minion team seems to have tampered with the shellcode and updated both the IP and port, preventing Glitch from connecting. The correct IP for Glitch is the attack box IP, and the successful connection port should be 4444. Can you help Glitch identify and update the shellcode with the correct IP and port to restore connection and reclaim control? What is the flag value once Glitch gets reverse shell on the digital vault using port 4444? Note, the flag may take around a minute to appear on NC user's Glitch desktop directory. You can view the contents of the flag by using this command here, type, and then the location, right? So go ahead and try to figure it out yourself. Then come back to the video and we will continue on. I mean, basically, it sounds like we're doing the same thing, except we're changing the port to 4444. Okay, let's take a look at what's going on here. Now, going back over to the attack box, and we need to change the port to 4444, right? So that's exactly what I did. MSFvenom, L port equal 4444. Got the new shellcode here. So remember to copy those because you have to use it later. All right, make sure your listener is changed to 4444 for the port. So that's ready to go. Everything's set on the attack box. Flip it over to the victim machine. You got to go through and repeat the steps we did earlier. Did all this here, okay? Except for when we get down to the shellcode area where it says buff equals, you're going to put in your new shellcode there, as I've already done. All right, now I'm on this final line. I'm going to enter. All right, now it should connect back. Let's go ahead and check. And there we go. Now let's see if we can find this flag. It said it may take a few minutes to appear, but you can see that we're on this machine again. So that host name, okay, looks good. Clear. Oh, okay, whatever. So let's go ahead and do type. There we go. Now we got the flag. Awesome. So that takes care of this room. And it says, are you interested in learning more about evasion? Take a look at AV evasion shellcode room. So take a look at this if you're interested in continuing on in this particular area. Now, as I said earlier, the generic MSFvenom shellcode is probably going to get detected by any antivirus out there that's worth its weight in gold. If it's worth anything, it's going to detect something like this, because this is well-known technique that that attackers use out there. So you got to use other tools, possibly create your own type of malware, or whatever, to try to bypass AV. But that's out of scope of this room. So that marks the end of this particular task and day. Hopefully you enjoyed this video. If you did, hit the like button, comment, subscribe to the channel with the notification bell if you're new here. As always, thank you all for taking time to watch my video. Have a nice day, and I will see you in the next one.